All right, welcome back. So, fifth example, fifth idea here is what if we have two functions that this is just not practical to integrate with respect to x. Think about making vertical rectangles, and our vertical rectangles, well, they're going to be a bit weird. And they're going to sort of be all over the place. So what we do in this case is we change up and we just say, well, let's have the fact that we have two functions, x equals f of y and x equals g of y, and we are starting at height c and going to height d. So this area becomes the integral from c to d of f of y minus g of y dy. Hey, guess what? It's exactly the same. There's no difference. Everything is in terms of y instead of in terms of x. We can calculate the area of this curve. And this is going to be true for functions that look like this. We want to find that area. And really what you want to do is you just want to look at your graph. And if you see an upper function and a lower function, oh, okay, looks good. We'll do this in terms of x. And if you see a left-right function, then you'll say, oh, well, let's do this one in terms of y. So what is the downside of doing it in terms of y? Well, possibly y equals x minus 2, y equals square root of x, and the x-axis. Okay, why did we choose to do it this way? Well, we're familiar with all of these functions, and we know that these intersect at 0, 2, and 4, and we said, well, that's pretty easy, and we wrote two integrals. We wrote an integral for this side, and we wrote another integral for this side. Well, let's rethink this problem in terms of functions of y. Notice that if I do it in terms of y, I only need one integral. This is y equals x minus 2, which means that x is equal to y plus 2. This is y equals square root of x, which means that x is equal to y squared. And this right here is the point 4, 2. Which means that my area is now the integral from 0 to 2 of y plus 2 minus y squared dy, which is, and we'll actually do the calculation here. So we got 1/2 y squared plus 2y minus 1/3 y cubed, evaluated from 0 to 2. Thankfully, we can just completely ignore the 0 because everything will be 0. So we get 2 squared over 2 is 2, plus 2 times 2 is 4, minus 1/3 of 8, 8/3. That's 6, that's 18/3 minus 8/3. And notice that we get the exact same area, but we only had to do one integral instead of having to do two integrals in order to split it up. So why don't you guys go ahead and do exercise 11, which will ask you to split this up slightly differently. And then we will be back with another example of why slightly more complicated, but making that choice. All right, thanks for watching.